Good morning. My name is Hannah Beeler, and I am the social media manager here at COSI. Thank you for joining me today for the 2021 COSI Science Festival. The festival has moved from a 4-day physical festival to an all-digital format May 5th through 8th. On May 8th, we hope you will connect virtually with at-home science activities and share your experience with photos or videos on social media using hashtag COSISciFest. And of course, we want to give a big shout out to all of the sponsors and partners of the COSI Science Festival, especially our visionary sponsor, Battelle. We certainly couldn't do this without them. Want to show your support for COSI? We are nominated once again for USA Today's 10 Best Science Museum. You can vote for COSI by visiting cosi.org/10best, and don't forget, COSI opens to the public on June 3rd. Now, it is my pleasure to welcome you to today's event.
Well, greetings. My name is Dorian Janney, and I work at Goddard Space Flight Center for NASA. And I'm here today with Andrea Portier, and we're going to be hopefully weaving a tale for you about how and why NASA, a very, very special NASA satellite, and some other satellites help us out as well, how we are able to measure where and when precipitation is falling all over the world. So let me go ahead and share my screen, and we will get started here. Let me just make sure, are we seeing my slides? Alrighty, everybody knows as we have moved into this world of kind of digital, just how crazy it can be sometimes trying to make it all work. But we're super excited to be here and tell you a little bit about how NASA is able to better understand how much precipitation is falling all over the planet. And what we really want to do today is to share with you why that matters, what we're able to do with this really neat information. But before we start sharing this information with you, we would like to get a little bit of background knowledge from you and get a feel for what you think and what you know about some things related to NASA. So we're going to start off. Put up what we like to call affectionately the NASA meatball. So when you see this logo, this NASA meatball, what do you think of? And you can just put your answer in the chat. Do you just think of astronauts? That would be A. B, space. C, planets. D, stars. E, Earth. Or F, all of the above. So go ahead and put what you think of when you see this logo in the chat box. And good. So I see somebody put astronauts, and certainly I see that a lot when I'm going out and working with people. And then I see another person said all of the above. Well, I'm happy to hear that some of you said all of the above, because indeed, not only does NASA study all kinds of amazing planets and stars and various things about our universe and send humans, astronauts, up into space, but we also study and care so much about our home planet, the Earth. So our beautiful home planet, Earth. When you observe our home planet, what do you see? You know, do you see land, water, both? What are kind of some of the things that you notice about this stunning home planet of ours? I'll just get a little audience participation here, and good. As many of you have mentioned, you see both. We see both the land and the water. So I have one thing I wanted to tell you about water. So water, this amazing thing that we're just so used to turning on our sinks and having fresh water. As a matter of fact, this happens to be the Center for Disease Control's drinking water week, clean drinking water, which most of us are incredibly fortunate that we have access to fresh, clean drinking water. Well, water itself is amazing. Water is actually composed, a molecule of water is composed of 3 atoms. Going to get a little chemistry lesson here. So we have 2 atoms of hydrogen, which are fused to 1 atom of oxygen. Well, a really neat thing that scientists have found out, and that is the very water that we drink was created when a supernova star, a huge star, blew up billions of years ago. And that water became a part of Earth. It came to Earth's surface and inside Earth when Earth was forming about 4.3 billion years ago. So the next time you take a drink of water, think about the fact that the water you're drinking is even older than Earth itself. It's a fine bouquet, possibly 8 billion years old. Really, really amazing stuff water is. All right, I have one last question for you, and then I will stop asking questions, and I'll just be giving you some information and then allow you to ask questions about how much of Earth's surface is covered by water. So we're talking about this cool stuff, water that came to us from supernova star explosions. Do you think about 25% of Earth's surface is covered by water, 50%, 75%, or 90%? I'll give you a second to go ahead and put your guesstimate, or possibly you're one of these astute people that just knows this because you studied it, learned about it. And come over here, and I'm going to stop sharing for just a minute.
And we're getting quite a few Ds.
All righty, wonderful, good to hear. So if you said about 75%, then you are correct. So it turns out that scientists have found, and I'm going to use this glass here as a model of Earth's surface, about 73%. So that's about 75%. About 3/4 of Earth's surface is covered by water. That's wonderful because, as we know, water is essential for life. We could go 3 weeks without food, but we could only survive for 3 days without water. And it turns out that the kind of water that we need, that we drink, and that most of our plants require is fresh water. So if we take all of this wonderful water on Earth's surface, 97% of it is salt water. So I'm going to take out about the amount that is fresh water. Just a couple of drops would be fresh water. So hardly any of Earth's water is actually fresh water. And we're going to learn a little bit more about that fresh water and then find out why is it that NASA satellites are studying fresh water, how important it is, and why we have this satellite mission to do that. All right, hopefully we're looking at my slides again, and I'll come back over here to my cursor button, which is down here, and push it again, push it again. All right, are we seeing my slides again? Fantastic. So of all the water on Earth, about 99% of that is not really usable to us. So the amount of water that is usable, about 1% of that, remember 3%, about 3% is fresh water, but of that, most of that is in ice caps and glaciers. And then some of it is in groundwater. And of course, we can get to that groundwater with wells. But hardly any of it is actually in lakes or rivers. And then of that water, only a tiny percentage is in our water cycle. I wanted to show you what we use fresh water for. It might surprise you. And this also depends on the country that you live in. But in developed countries, it turns out that about half of our freshwater usage goes to create power. And then some of it is in our public supply. Some of it is being used for irrigation when we don't have precipitation falling and we need to irrigate our plants. Some of it's used for aquaculture, mining, livestock, and then domestic use. So it might surprise you that of all that water, most of it is being used to generate power. And when you think about that, you think about the fact that we can't really use salt water when we're trying to cool down things, for example, with nuclear power plants when they get really hot, and so do other types of power. When we're creating power, you're generating heat. So to cool off your engines, your machinery, you need to put fresh water on. It has to be fresh water instead of salt water, because of course with salt water, once the water evaporates, the salt is left behind, and that would get into your machinery and really mess things up. All right, we're going to watch a short video that's going to tell us a little bit about where the water is, and is going to introduce a little information about the Global Precipitation Measurement Mission, which is the mission that both Andrea and I support.
As humans, we're well aware we need water to live. Fortunately for us, we live on a water planet. But that doesn't mean we have an entire globe of H2O to use as we please. So just how does the usable water break down for us? A giant 97% of Earth's water is in the ocean, so we can't use that. 3% is fresh water, but even in that small sliver, about 2% is locked in glaciers, ice caps, and groundwater. That leaves about 1% of the fresh water on Earth that is accessible and usable by humans. Let's imagine all of that accessible fresh water fits into this tiny pool. Now we'll get to some small numbers when we look at global freshwater. There really is a small fraction of usable and accessible freshwater on this water planet, so how do we use that tiny pool? In the United States, about 49% is used in thermoelectric power production, while agricultural irrigation makes up about 31%. 11% goes to public use in our cities and towns, 4% goes into industry and manufacturing, and 1% is domestic use. The water coming out of our faucets largely comes from precipitation. Measuring how much or how little precipitation falls can impact how we live our daily lives. Elsewhere around the globe, in developing countries, agricultural irrigation accounts for about 70% of freshwater use, while industrial use is 20% and 10% for public consumption. In places where access to usable freshwater is greatly limited, knowing when and where precipitation may fall is critical to livelihoods. Precipitation replenishes these tiny reservoirs of fresh water, and data from the Global Precipitation Measurement Mission will help farmers, ranchers, and policymakers in these regions plan for periods of drought, flooding, and other extreme weather.
Whet your appetite for learning more about the next slide. There we are. Learning more about how this satellite mission is able to measure global precipitation and find out how and why these data are being used to improve life on Earth. So I'm going to just stop here and see if there are any questions before Andrea takes us into explaining about how this satellite mission works and how it's able to measure global precipitation. I have been working with NASA now for a decade, which is 10 years. Before I worked with NASA, I was a teacher and I taught all grade levels. So it was fun to come over and start working with NASA's scientists and engineers, learn about this satellite mission before it launched. And so I came over 3 years before the satellite mission launched. I came and started learning about it, and it launched in February of 2014. So now we have been up for several years. All right. Well, of course, we'll take some more questions a little bit later. And now it is my great pleasure to introduce our applications coordinator. So that means with Andrea, what she's doing is she is working with people that are using our data or might want to use our data and are going to be finding out how they can use and access GPM data for a wide variety of different applications. And I'll just quickly answer this question, then I'll stop and be in. I actually, with NASA, I started off just working with one mission, but now I support largely lots of different missions. My main focus is the Global Precipitation Measurement Mission, but I also help lots of different audiences learn about the ways in which NASA satellites study Earth. So, all right, Andrea, over to you.
Thanks, Dorian, for that great introduction. I'm excited to be here. Once we have the PowerPoint showing again, I'll dive into it. And, you know, just as a reminder, before we get into the Global Precipitation Measurement Mission, or GPM, is that I want to kind of hit a note for you guys all, is that what Dorian mentioned is that Earth is a planet too. So it's just as important for NASA to study other planets and Earth. We live on Earth, and so it's really important to understand the processes that go on Earth. So having a view from space and looking down at Earth has several advantages. It can help us understand how the planet works, how Earth changes, what causes these changes, how will the Earth system change in the future, and how can Earth system science provide societal benefit? And Dorian, if you could hit that video again in the previous slide. And if we could expand the screen a little, that would be great. So what you're seeing on this right view of the screen is a view of Earth and some of the data that NASA is able to capture. By looking at from space down to Earth, we can understand the amount of rain, where and when it's falling. We can also understand when that rain falls, how does that impact soil moisture? So how much the ground is wet, and then how that impacts vegetation. We can look at salinity changes. That means how much salt is in waters from large lakes to the ocean. We can even look at vegetation changes, and all of that plays a role in all the systems together. But we can even look at dust that impacts our air quality. So having that view from space really has several advantages. So now let's go on to the next slide. One thing I do want to hit home is that NASA has over 24 satellites that are in space that are monitoring what we say is the pulse of the planet, monitoring those changes that are occurring daily on Earth. And one mission that, again, Dorian and I work for is the Global Precipitation Measurement Mission. And we measure precipitation. So from anywhere from rain, sleet, and snowfall. So let's go to the next slide. And before we dive into this video, one thing I want to highlight is that, yeah, we had this global view, but I really want to talk about the importance of what satellites bring to measuring rain and how that can help us understand more about the water cycle. And also, I do want to recognize that we have fantastic videos and resources on the GPM website. So please reach out to us if you want more information. So I'm going to let Dorian play this video, and it's just a couple minutes long. The sound isn't working. Hey, Dorian, the sound is not playing. Hi, Hannah. You mentioned in the chat about pulling it up on YouTube. If that's best, is there a way that you can do that through this interface? All right, let's see if. All right, sorry for the technical difficulties. Just hang on one second. Okay. All right, I'm gonna try to share my screen and see if this works. Oops. Was everyone able to see that video? Great. Dorian, do you want to share your screen again? Fantastic. Thank you, Dorian. All right. So what you just watched was a video produced by GPM at NASA Goddard, which is one of NASA's centers. And what we were trying to show and illustrate is the importance of measuring precipitation from space, because we can't cover the ground all over the world, especially in the oceans that are vast. So again, having that view from space really has that advantage of measuring the precipitation all over the world. And so talking about GPM, the actual satellite that helps measure precipitation was built at NASA Goddard, and it actually is as almost as large as a small fire truck. When it was launched, it was one of the largest satellites to be launched in space. It carries advanced instrumentation on it. And one thing that's interesting, it has solar arrays to basically take in that solar energy to help the satellite maintain its orbit, so to go around Earth, but also help the fuel to keep that satellite going for years to come. On this GPM satellite are two instruments, two very advanced instruments. One is the dual frequency precipitation radar. What that means is that it's an active remote sensing tool or sensor, which sends pulses of energy or heat down to Earth to collect the different precipitation, anything from very light rain to heavy rain and snow. But because these pulses of energy go so fast on Earth, it can also collect the different raindrops that are falling from the sky down to the Earth's surface. And so what it can do is actually produce a 3D structure of a storm. So anyone that has had to have a CAT scan of their brain and have a 3D view of your brain, that's what the GPM DPR can do as well. It can take a 3D view of a storm and really see what's going on inside of it. The other instrument on board the GPM is called the GPM Microwave Imager. It is a passive remote sensing tool, which means that it collects the natural energy that's being emitted from Earth, especially from the precipitation, so raindrops, back to the satellite. And that can give us a a surface view of what's going on and how much rain is falling from light rain, heavy rain, and snow. But what's really interesting about the GPM is that we can't just use this one satellite to cover all the precipitation that's going on Earth every minute of every day. So GPM works with what we like to call is a constellation of other satellites. And so Dorian, can you go to the next slide? Thank you so much. So what this constellation means is really a team of other agencies and organizations throughout the world, from the European Space Agency to the Japanese Space Agency to even the Indian Space Agency, and then other agencies in the US. What we do is that we use their satellites that help measure precipitation all over the world. Those satellites basically send their precipitation information, that rainfall information, to the GPM satellite, what we call the GPM Core Observatory. Now, what we're able to do is, because it's sending that precipitation information, we can have that global view from our satellite. And so what you see this video on the right is a video of the constellation measuring precipitation and how we can get a global coverage every 3 hours, which is amazing because this is very beneficial from anywhere from disaster response to agriculture and water resources issues. Next slide. So what you're seeing here is, after taking all those measurements of precipitation along with that constellation, we can give this near global coverage of precipitation, especially where the majority of the population lies, even in the tropics where a lot of rainfall goes down. And so what you see here is one of the GPM data products called the Integrated Multi-Satellite for GPM product, or iMerge. What that means is that we are able to take all that information precipitation and put it onto where the precipitation is falling on a map. So people like us can understand when and where precipitation is falling all over the world. And this actually can be provided to people every 30 minutes. Next slide. So now, talking about all the technical information about GPM, how it can measure rainfall, how we work with a team of satellites, why is that important? Why do we care? Well, as Dorian mentioned, it's essential to understand when and where water is falling. Water is the most precious resource, but also it can impact us on our daily lives, such as if there's a lot of precipitation or even heavy snowfall, it could impact the roads, and it could be poor driving weather. If we had too little precipitation, that could lead to drought, which could affect many crops growing. But also, if we had standing water from too much precipitation, that could attract mosquitoes, which could potentially lead to malaria outbreaks. So as mosquitoes bite people from different parts of the world, it can infect them with malaria. We also, if there's a lot of precipitation or huge storms such as hurricanes, that can severely affect where one lives, from their homes to their safety. And so we need to coordinate effectively how to help these people move away from those areas that are in danger. So let's go to the next slide. So what now I'm going to do is actually talk about specific examples of how GPM data measured from space is helping us in real world society. So what you have here is two photos. The one photo on the left is a view from the GPM DPR, the one that it's the instrument that measures 3D precipitation structures. What it did was it was able to capture this huge thunderstorm that was going over Oklahoma at that time. And there was storm warnings all over Oklahoma during this time. The picture on the right is actually from the GMI instrument to give you the amount of rain that's falling in a 2D scale. And so the idea of this is understanding how tall the storm is, where the areas where it's most intense precipitation to where the light areas of precipitation. We're able to share this information with, let's say, the National Weather Service that provides those warnings to people in those areas to go to safety as needed. Next slide. Now, moving across the world to India, we have a group of people that are actually using precipitation data to track when and where elephants migrate. Is there a relationship between where elephants go and precipitation? The reason being is that elephants and humans, although it's great to see elephants, what can happen is that there can elements invading farms can bring harm to humans, but also them invading farms can also bring harm to elephants. So if we're able to understand the relationship between precipitation and elephants, it might help reduce the impact of what we call human-elephant conflict. Next slide. So in 2019, Iran had very severe and heavy rainfall, which led to severe flooding throughout the country. And so what the European Coordination Center does is they help with disaster response and relief. And so the two maps, I know it's rather small, but the idea is that the European Coordination Center is that they take in multiple environmental information, such as precipitation data from GPM. And what they're able to do is use that data, thanks, Dorian, use that data to help inform where rainfall was most heavy, but also where it could lead to flooding. The reason being is that that is essential for disaster aid and relief organizations. They're able to go to areas that are at most risk first, and then coordinate how they work with other communities working out from that area of that risk. Next slide. So moving back to the United States, especially in the Southwest, we have a tribal community called the Navajo Nation. They live just north of what the Southwest receives this heavy rainfall occasionally. But because the Navajo Nation just lies just north of this area that receives heavy rainfall, they suffer severe drought, which leads to insufficient water resources for the community, from anywhere from drinking fresh water daily to also crop production. So what a team of NASA researchers are doing is that they're working directly with the Navajo Nation using satellite data and on-the-ground gauge data to help predict times when it must be most prone to drought. And the reason why is that then they can lead to effective irrigation practices, so saving that fresh water as needed. Next slide. We even have people from the USDA, it's the Department of Agriculture in the US, who are actually looking at precipitation all over the world. Why is that? Because understanding when and where water falls impacts crop production. And just like many other countries, we don't solely rely on food that's grown in the US. We rely on food that's grown all over the world to be imported to us, but also we want to export crops as well. But knowing when and where water falls and how much or how little helps us understand if there's going to be a good crop production, there's little crop production, what may be impacted for the economy. So again, by knowing this really has a lot of information for USDA to carry out their services for farming communities. Next slide. All right, that is it for me. I'm happy to talk about several other ways that the application of GPM data is used for society that impacts us directly. But what I am going to do is pass it over back to Dorian. Thank you, Dorian, for navigating the slides. I super appreciate it. And again, please ask your questions. We're happy to answer them when we can.
Thank you so much. And you bet. Yeah, we will be staying on after I'm going to be sharing with you a couple of our new resources, which are spotlighting, kind of highlighting some of those really cool applications that Andrea was talking about. And so once I show you a couple of these resources, then we will stay on and answer any questions that you might have. So let me go to the next slide. Like I'm running a three-ring circus here. Okay, hopefully the sound's going to work on this, and if not, I've queued it up so that I can put the link up. So let's see how this goes. This is our newest video showing
animals migrate all over the world. And if we want to be able to look at those global migrations, and if we also want to be able to network and compare data about animal movements and behaviors in different regions, different species in different parts of the world, and over long periods of time, we really need a global database for that. So one tool we offer in MoveBank is called the Environmental Data Automated Track Annotation System, which or for short, ENVData. And this is a free service that lets researchers and the public link animal movement data to environmental information from remote sensing products and weather models from NASA and other providers, including the GPM precipitation data. And so by connecting these data sources, we make it much easier for researchers to investigate questions about how animals' movements and migrations are affected by the environment around them. Part of climate change is a phenomenon called polar amplification, which means that the rate of warming is going to occur more quickly at the poles, at the North Pole and the South Pole. So in the Arctic, we're seeing warming rates more than twice as high as the global average. So this is causing really dramatic changes in what animals experience. In this recent project led by Dr. Peter Mahoney at the University of Washington, we looked at how movement speeds of different animal species change with precipitation and temperature. And so we looked at data for more than 1,700 animals, and we found that movement speeds of wolves, caribou, bears, and moose did not seem to be affected by heavy summer rains, but that wolves, moose, and boreal caribou moved less where there was higher snowfall in the winter. We also found that at higher temperatures, some species moved less while others were moving more, which could impact predator-prey relationships and ability to find food as global temperatures continue to increase and as precipitation patterns change. We link almost entirely to globally available data sets. The same methods can be used anywhere in the world. This means that researchers can make assessments across migratory routes of species traveling really long distances, make comparisons across regions and species, and this also makes it easier for researchers in different countries to work together.
So we hope we're kind of whetting your appetite for some of the, the really amazing ways in which these data are being used for a huge variety of purposes. Last thing I'm going to show you, and then we're going to start answering your questions, is not only do we have these really cool videos that we have been able to work with our video producers and create, but we also have some products. And let me go. I saw one of the questions was how to encourage females to go into STEM careers. So what I wanted to do here is take you to the site that I have put into the chat. And on this site here, we featured some of the different people, and we have here our two young early career female scientists. And what we did is we came up with a variety of different products that you can go on and you can look at. Some of those products are things like interviews through, this is something called a story map. So it's an interview with Sarah Davidson. You can go in here and learn a little bit more about the GPM mission, more about the applications like we were talking about, see that video that I shared with you. And then you can go in and actually learn from Sarah, hear her telling about some of the studies that she worked with, and then doing an interview in which she's telling us about her career, how she got into her career, what interests her, what are some of the frustrations she faces, while she works. So we have featured Sarah. We've also featured an amazing woman named Liz. We call these two data heroes because in this case, they're working to take these data that are coming from the satellites and make them more easily accessible and obtainable by different people who they know could benefit from having that data. For the one we looked at before, Sarah, the one who was focused on in that movie, she's working with animal ecologists. Now, Liz is a data hero in a different way. She's working with people who are suffering from water insecurity and they don't have enough fresh water. So helping them to better understand where the freshwater resources are and come up with some more equitable solutions for ways in which they can utilize that water. She also showed ways in which the data are being used to help people predict landslides and even be able to respond to the threat of wildfires. So when you get a chance, go in and take a look at the work being done by Liz. We also last year featured some work being done by Faisal Hussain. He is a professor of civil and engineering and environmental engineering, so kind of neat to learn about that career. He grew up in Bangladesh where there was not enough freshwater resources for people. And what he did is he was able to work with farmers and was able to show farmers in Pakistan, Bangladesh, and India how they could use the information from the GPM mission, and basically they would just get texts letting them know whether or not they needed to irrigate, to divert water from the river that flows close to them and use irrigation for their wheat fields, or if instead they could rely on precipitation. I generated a couple of lesson plans. So if any of you are teachers or students, take a look at those lesson plans. They're kind of neat way of learning about wheat production, and why the GPM measurement mission is so important and how that data is being used. And then we have another really cool story by a gentleman named Icar Ibarres, who lives in I believe he lives in El Salvador. And he works with microinsurance policies to ensure that small farmers and even people who are selling artwork, whose tourism work depends on whether there's precipitation or no precipitation. If it's raining for 3 weeks, then perhaps this local artist there's no tourists out there and she's not able to sell things. So they can just use looking at the GPM data rather than having to go through other middle people to determine whether or not they should get funding for that time that they weren't able to work with people. Of course, they help us for hurricanes. You can learn about that, help us better understand and monitor vector-borne disease, respond to malaria, cholera, a wide variety of different things that we have available on our precipitation education website. We have lots of different resources, all the videos that we showed you earlier today. And then if you go to resources and programs, and you can take a look at who's using GPM data. You also can come in here and take a look at, let's say we whet your appetite and you're like, I'd like to access that data and take a look at it myself. We have lots of information here for how you can access this freely available data. And if you follow this activity here, from satellites to your backyard, it will help you be able to put in your latitude and longitude and find out how much precipitation, global precipitation measurement mission measured for that specific area anytime over the past 20 years. So hopefully all of this tastes like more. And I will stop sharing now, and then both of us will be here to answer questions. Let's see what we have here. Maybe, yeah, go ahead.
Oh, sorry, Dorian. I was going to say, I scrolled up. There's 2 questions near the top, where one is, do either of us have a favorite project we have worked on?
That's such an interesting question. I guess one thing that for me was fascinating was when I found out that water was made from supernova stars exploding. That was just one of the kind of favorite tidbits of information I had. I think that's so neat. I love when I get to work with these end users and learn about the amazing work they're doing. It's hard to say a favorite, and that it's just so interesting. And Andrea?
Yeah, so I'm going to echo a little bit of what Dorian said. It's really hard to pinpoint a favorite project, but there are just so many. A part of my job, as Dorian mentioned, is I work with a range of end users. And when we talk about end users, those are people that are interested in using GPM data to help make decisions for society, such as end users of NASA researchers in the Navajo Nation, to end users from USDA, or even end users from the insurance industry. And so my favorite part is talking to these end users to, again, explore how they're using the data. But one thing that's important about my job is that I get to meet all these incredible people, understand their data needs. And part of my job is to communicate that information back to the GPM science team, because we are always looking for ways that we can improve our products and services for the public that can help directly benefit society. And then I guess next question would be, what have each of your career paths look like? Dorian, do you want to take it?
Sure, I'll jump in there to say, so I started off as a teacher. I started off teaching early childhood special education, and then I just fell in love with learning, and especially with science. So I went back to college and I got another master's, and this time it was in earth space science, because that was what really was fascinating me. And so I found that the best way of teaching my middle school and later high school students was through astronomy, because everyone just always, they're fascinated by dinosaurs, and then they're fascinated by stars and the galaxy, and, that sort of thing, as was I. And I just kept finding the more I learned, the less I knew. So I started working with a lot of NASA products as I was teaching. And then I was asked, well, hey, would you be interested in coming over and serving as the interpreter for learning about what the GPM mission is going to do and what the mission that came before it, Tropical Rainfall Measurement Mission, has been doing? Would you learn about that and find ways to translate that to the public? So, my career path went from being wonderful that I had taught so many different grade and age levels and also worked with adults, because it helped me to be able to work on finding different ways to make what we're doing with the GPM mission and also NASA's other Earth science missions more understandable and interesting to the general public.
And my career path was slightly different. I actually went to Ohio State University, so directly in most of your backyards. And there I actually majored in geological sciences and international studies. So what I wanted to do was apply real world sciences to everyday activities. And so one thing I fell in love with is chemistry. And so I really explored looking at the interactions between water and rock and the breakdown. And I just loved how that could impact us from anywhere from freshwater resources to where we live from landslides. So I decided to go to graduate school, but I actually kind of switched gears and really took a deeper dive into paleoclimate, exploring the past climate over 3 million years. But I realized as I was doing all this technical research, I loved communicating to the public. I loved engaging others because it always kept me on my toes. It always kept me to learn. So I, looked at jobs and careers. I worked at the National Science Foundation prior to NASA, where I actually worked for the Marine Geology and Geophysics program. So not what you think of when you think of NASA. So I was looking at hard rock and ocean activities. But again, I loved engaging the scientific community. And that's where what helped me bridge the gap to NASA is that I loved the interaction with end users. I wanted to communicate the science so it can be used by end users that might not be familiar with NASA data. And that's where it got me to be as a NASA GPM applications coordinator.
Kind of neat sometimes how you find how your career just kind of moves into these different directions. And a lot of it is, of course, getting out there and networking, things that you're interested in, things that you learn about, interact with different people, and that will help you then to get a feel for, what you want to do when you grow up. So, and it's kind of neat for me as an older person going in a new direction, after that.
I think that's that's a great point to make, is that I think both of us can say is that we didn't necessarily think of working at NASA once we started our career paths or even in college. And so, it's flexible, you navigate your own path to make it what you want. And I think that's what's awesome about NASA. There's so many opportunities here. There's so many ways that you can be involved with the scientific community from the outreach side and engineering side. So again, a path is usually not set in stone for careers.
And I see another question. Do you ever interact with astronauts? And I will say, so we both sit when there's not a global pandemic. We both work at Goddard Space Flight Center, and there we certainly have a few people who work there who are former astronauts, but we are not the location where the astronauts would be doing their training and would be working. That's in another location, I believe in Houston, and then also in Florida. But we certainly do interact with former astronauts, especially at big events. And another one is, how can we encourage more women to go into STEM fields? I'll start that and then let Andrea give some more information. That's part of the reason why I like to highlight these STEM professionals, and I like to try to work on finding them from people who are underserved as far as being in STEM careers. So we do see that with some of our underserved minorities, and we also see that with women. So by highlighting and showcasing some of these amazing people of color or females, telling their story, how they went into it, what they're able to do with their career, I think that's a good way. And another thing I'm finding is that now that I've been in the career of teaching for 30 years and then gone over to now work at NASA, I'm seeing that there have been a lot of things that are starting to make the careers more friendly for those, for parents. So that's not, of course, not just women, but, particularly, in the case of, say, women who are nursing, they have, special rooms that are nice rooms where they can go and pump if they need to, or just these sorts of things that make it family friendly. And not all women have children, but for those who do, sometimes that could be a bit of a roadblock. So finding ways to make these STEM careers be more fluid and flexible and inviting. And Andrea?
I think you nailed it. I'll just echo and emphasize the part of creating awareness in these of these examples of women that are in STEM, how they got to be where they are and what they're doing. I think it just encourages people from the get-go. And so again, having those examples, getting those women to speak out and talk about their experience, I think is important. So I'll just stop it there.
Well, thank you. And this is a really good one for, I'm wearing a shirt that says every day is Earth Day with NASA. And what are some ways that we can be more environmentally friendly to our fresh water? That's a great question. And of course, the easy thing is really, really watch pollution. Watch things like when you're emptying, if your car is leaking oil or fluids, those then go into our water cycle. Once it rains, they get washed down. Don't use too many fertilizers. Be really, really careful about the different kinds of products that you're using, because, eventually those go into our water cycle. Another thing to be cognizant of, and this depends on where you live, it's, location, location, location. In my region where I live in Maryland, we get about 5 inches of precipitation all year long. That's another neat thing you can learn when you look at your precipitation data from satellites to your backyard. But so we get enough precipitation that we don't have a concern right here in Maryland about not having enough fresh water, except occasionally in the summer we might have a drought. So I don't have to be quite so concerned about how much fresh water I use, like always being sure I turn the tap off right away when I'm taking a shower or brushing my teeth. I'm still careful. But if you live in an area where your freshwater resources are limited, find ways to reuse your water, your gray water, and that sort of thing.
Yeah, I was just going to say even something on a very small scale, environmentally friendly to our freshwater, conserving, the amount you water your own lawn. Is that necessary? To even taking long showers or multiple showers a day, is that necessary? Is there a way you can cut back? So I think thinking of even little things such as that can have an impact as a whole if we all start thinking more about it.
And the last thing I'll do, and then we'll close things up, is when possible to use a refillable water bottle. Because when you get those plastic water bottles, nobody has stars that they're exploding and they're creating their own water. They're just taking that water from our water cycle. So your water, most likely where you live, is clean, is healthy. If you want, run it through a Brita filter. But every time you buy those little plastic bottles, sure, they're recyclable, but it takes energy to make them. It takes energy to take them from whoever took them from the water to, taking that water from wherever lake or stream they're taking it from to wherever they're going to bottle it. Then from where they bottle it in the factory to the grocery store, then from the grocery store to your house. So when possible, don't drink that water from those little plastic bottles. Refill your water and drink a lot of fresh water. We hope that you've learned a lot about water. We hope that we've kind of excited you about the really neat ways that NASA is studying our home planet and helping us to be able to conserve our most valuable natural resource, and that is our freshwater resources, and some of the cool ways in which those data are being used by a multitude of different applications. And thank you, COSI, for having us.
Thank you.